Hello, gang. So today we're going to be working on lesson 1.4, and we're going to be talking about powers of 10 and exponents. All right, so what I did here is I have this slide presentation that I can kind of introduce powers of 10 and exponents to you. And we're going to be learning what they are and how we use them. Okay, so I'll start with that, and then I'm going to get into the book. So here's some definitions and an example. So over here's your example. Okay, this number, the larger number, is your base, and then the smaller one is the exponent. Okay, so that 3 is your exponent. That's what it's called. And an exponent tells the number of times that the base is used as a factor. So we're using this 10 as a factor 3 times. That's what it's saying. In the number shown here, the base number of 10 is used as a factor 3 times. A power is the value of an exponent in an expression. When the base is 10, like here, the number is called a power of 10. Read the number as 10 to the power of 3 or 10 to the third power. There is a pattern to the number of zeros in powers of 10. And we're going to check out a table on the next page. So what they're saying for that 10 to the third power, if we're looking at 10 to the third power here on the chart, what you're really doing is 10 times 10 times 10, okay? And that standard form, if you multiply 10 times 10 times 10, it's going to give you 1,000, okay? Because really what you're doing, 1 times 1 times 1, that's 1, and then you count your zeros and you add it to your number. So powers of 10 chart, look at the table. The exponent represents the number of zeros in the standard form of a number. Each digit of a number is standard form. Let me reread that. Each digit of a number in standard form is in a place value. So each time the exponent increases by 1, the number of zeros increases by 1. So hopefully if you look here, you have 10 to the first power. And then that's just going to give you 10. 10 to the second power would be 10 times 10, and that gives you 100. 10 to the third power is 10 times 10 times 10, or 1,000. 10 to the fourth power is 10 times 10 times 10 times 10, and that gives you 10,000. Look at the number of zeros in your standard form. 1, 2, 3, 4. Look at your exponent. It's a 4. So the exponent is the number of zeros in your standard form. Okay, check out the other examples here. Goes all the way to 10 to the 10th power. Okay. All right, so here's another chart. You can see it on here too. It's another chart. But what I did is I linked this chart to a quick game. I'm not going to do that right now. If you want to go ahead and try it out on your own, I've attached this slide presentation to our assignment for today, so you can check it out when you get a minute. All right, but I am going to show you this quick little intro video on exponents and powers of 10.
Grammarly can help you write quickly and confidently, so you never have to slow down at work. Instant corrections make your writing mistake-free, while keeping it short.
Welcome to 5th grade math with Mr. J. So in this video, we're going to be going over powers of 10 and what powers of 10 are, and we're also going to be looking at patterns within powers of 10. That's very important. And you might be thinking to yourself, what the heck are powers of 10? I promise by the end of this video you'll have a pretty good understanding and you will see some patterns within the numbers we're talking about here. So this is the instructional video, and the best way to learn about powers of 10 is just doing some examples. Okay, so we're going to start down here, and I'm going to start with our first power of 10, which is just 10. okay? And 10 equals 10. And you'll see why I'm putting an equal sign here as we go down. We all know what 10 is. Now let's do two 10s. Let's do 10 times 10. And hopefully we know that 10 times 10 is 100, equals 100. Now as I go down, see if you recognize a pattern here. Let's do three 10s. 10 times 10 times 10 equals 1,000. How about four 10s? 10 times 10 times 10 times 10 equals 10,000. And then let's do one more. Let's do five 10s. 10 times 10 times 10 times 10 times 10. If you're noticing a pattern, you can probably figure out what this is going to be right away. And hopefully you're thinking 100,000. Now, I could go on forever. I could put 10 times 10 times 10, 100 times if I wanted to. But let's cut it off at 5. This is plenty to recognize our pattern. And if you haven't caught on yet, I would suggest taking a look at the amount of zeros in our number here. How many are there? 1, 2, 3, 4, 5. How many 10s did we multiply together here? 1, 2, 3, 4, 5. It matches exactly. This right here, when we expand our 10s out, we have 5 10s there. We can call that expanded form for our powers of 10. Expanded form. This right here, where we write out our numbers, 10, 100, 1,000, 10,000, 100,000, is just standard form. And then this next one might be new to you. Exponential form, which is 10 to the 5th power. And all that means is expand 10 out 5 times. 10 times 10 times 10 times 10 times 10. I think I got 5 there. So let's do this one. Sorry, let me back up. That is exponential form. Exponential form. Because we use an exponent. And I'll talk a little bit about an exponent here in a second. So this one, we have 10 to the 4th power. 4 10s, 4 zeros, exponent of 4. It all matches. 10s are nice and easy to work with because these patterns, work for 10s. This one we have 10 to the power of 3, or 10 to the 3rd power. Here we have 10 to the 2nd power, or 10 squared, or 10 to the power of 2. And then for this first one, we have 10 to the 1st power. Notice our pattern as we go down. Numbers of zeros, numbers of 10s, and the exponent all match. Now a little short lesson on that exponent, the exponential form. Our 10, the bigger number, is called our base. And it is the number we expand out however many times our exponent tells us. Let's do 10 to the power of 2. This, our little number in the top right, is called an exponent. Now the most common mistake is to say 10 to the 2nd power equals 20. It means 10 times 2. That is not correct. It means expand your 10 out twice, which means 10 times 10, and that would give us 100. So exponential form, expanded form, standard form. And those are our powers of 10. So that's a little intro video. I put a link to the Mastery Check video where you can try some on your own. So if you think you're ready to go ahead and try some powers of 10 on your own, click that link. I'll see you over at that video. Thanks for watching. Please hit that subscribe button.
Okay, so hopefully that clears up a little bit what a power of 10 is and an exponent. Let me see. All right, so I'm going to use this. This is actually a song, and I'm not going to play this right now. It's a little song to help you kind of remember what a power of 10 is and an exponent. So you can check it out on your own time when you have a minute. On the next slide here, there is some practice problems. But what we're going to do is I'm going to come back to this after we do some of the work in the book first, and then we can use this for practice, okay? So let me go ahead and get this book going here. So this, once again, this is lesson 1.4, and we are doing powers of 10 and exponents. Let me just check, make sure it's still recording. It is. Okay, good. All right. So our essential question, how can you use an exponent to show powers of 10? If we unlock the problem here, it says expressions with repeated factors, such as 10 times 10 times 10, can be written by using a base with an exponent. The base is the number that is used as the repeated factor. So right here. And the exponent is the number that tells how many times the base is used as a factor. So the 3 tells us to multiply that 10 3 times. So that's what they did here. 10 times 10 times 10, which would also be represented as 10 to the third power, or the third power of 10. Okay? And that in standard form, they both equal 1,000. So there's 3 different ways right there to represent 1,000. Okay? So this would be your word form, the third power of 10. And I was taught growing up to say 10 to the third power. And that's okay too, you can say that. And then this is the exponent form right here. Okay? So now, it says, what is 10 times 1,000 written as an exponent? Okay? So what they're saying here, once again, they're coming back to our base 10 block. So we have our 1. So if you have 1, you would have 10 to the 0 power, or the 0 power of 10. That's represented as 1. Okay? Then the next one, if you have 10 ones, that would be like 1 times 10, or 10 to the first power. The next one is 100 ones, or it would be 1 times 10 times 10 times 10, and that's 10 to the second power. The next one we have are 1,000 ones, so you have 1,000 of these guys in this cube, and that would be like 1 times 10 times 10 times 10, or 10 to the third power. Okay? So they're just kind of showing you a pattern there. Okay? So they're asking, how many ones are there in 1? Well, there's 1. Let me get my text tool. Oh, I already have it, so that's good. All right. There's 1. The next question says, how many ones are in 10? Well, think about it. How many of these are in 10? There's 10. And then how many tens are in 100? So how many of these are in 100? Okay, so 1, 2, you could count them if you wanted, but you should know that there are 10. Okay. Let me just, okay. So they're saying, think 10 groups of 10, or 10 times 10. That would give you 100. Okay, how many hundreds are in 1,000? So now they're saying, how many of these flats are going to be in a cube? Well, that's also going to be 10. 10 of them. So they're saying, think there's 10 groups of 100 or 10 times 10 times 10. There you have, that would be 1,000. Then they want to know how many thousands are there in 10,000. So now once again, they want to know how many of these thousands are going to be in 10,000s. And we don't have a cube over here, but if you figured out the pattern already, you should have. It's 10. There are going to be 10 of them. Okay, it says in the box at the right, draw a quick picture to show 10,000. So what we're going to do is, let me do this. Let me just put a T. Let me draw a box. Hold on. Whoops, got a circle instead. I didn't want a circle. Let me group those guys together. Let's clone it. All right. And actually, let me do an infinite cloner so I can just grab it. Because what we're going to do here, guys, is we're using T for 1,000. So we just said, now we want to know how many thousands are in 10,000. So we said 10. So how many boxes are we going to draw? That's right. We're going to draw 10. We're going to draw 10. So go ahead and do that. I'll move these over. So keep it on the screen for you. I'll just put this one up here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go ahead and draw your boxes. Okay. All right. And then it says, so 10 times 1,000 is 10 to what power? Once again, remember that your zeros relate to your exponent. So if we look here, you have 1, 2, 3, 4 zeros. So your exponent's going to be 4. Same thing over here. 10,000 ones, or 10 times 10 times 10 times 10. Once again, how many zeros do you have? 4. So it's 10 to the 4th power. Okay? All right, let's go to the next page here. I thought this one's really neat. I love this hummingbird here. And I found this really cool hummingbird video. Actually, I think Mrs. Lewis found it and she shared it with me, and it's really neat. So I wanted to share it with you guys in a second, but let me read this first. It says, multiply a whole number by a power of 10. Hummingbirds beat their wings very fast. The smaller the hummingbird is, the faster its wings beat. The average hummingbird beats its wings about 3 times 10 to the 3rd power times a minute. How many times a minute is that written as a whole number? Okay, so what they're doing here is they have a pattern problem here so that you can figure it out. So the first part, they have 3 times 10 to the 0 power, so that would be like 3 times 1, which, wow, making it real hard on you guys, aren't they? What is 3 times 1? You got it. It's 3. Okay? The next one then would be 3 times 10 to the first power, and that would be like 3 times 10. So what's 3 times 10? That's 30. Then 3 times 10 to the second power is like doing 3 times 10 times 10. Because look, you have a 2 as your exponent, so that means you have 2 10s. Okay? So 3 times 10 times 10, well, you know 10 times 10 is 100. And then 100 times 3 is 300, right? All right. So then 3 times 10 to the third power would be like taking 3 times 10 times 10 times 10. Once again, 10 times 10 times 10 is 1,000. And then 1,000 times 3 would be 3,000. So the average hummingbird beats its wings about 3,000 times a minute. Think about that for a second. 3,000 times in 1 minute it beats its wings. That's crazy. Super cool. Let me show this video. I think you're going to really like it. It's pretty cool. Oops, get out of there. There we go. So super cool. What a beautiful bird. If you guys ever have gotten the chance to go up to Hawk Mountain Sanctuary and gone into the nature center there, they actually have hummingbird feeders, and if you sit inside there, you can see, and I'm not sure if it's open yet or not, but you can look out the windows and see all kinds of cool birds. I love birds, so that's one of I love doing that. But they have hummingbirds there too in the gardens. Super cool to see. If you haven't seen one in person, they really are beautiful. So you should check them out. I just thought that was pretty cool. All right, so let's look at this. It says, look for a pattern. What pattern do you see? Well, what do you see between the number of zeros and the exponents? So let's look for right here. You have a 3, but there are no zeros. Oh, well, guess what? Here's the exponent 0. Here you have 1 0. Here's 1 in your exponent. 2, 2, 3, 3. So what pattern do you see? Well, for each power of 10, the number of zeros is the same as the exponent. So let me get my thing. For each power of 10, the number of zeros is the same as the exponent. Makes sense? Hopefully. Move that over for you. Pull this up a little bit. All right. So let's go down and let's practice a few now. Write in exponent form and in word form, okay? So we have 10 times 10, okay? So now I'm going to have to write this because I don't have an exponent tool here. So let me get a pen. No magic pen. We don't want it disappearing on us. How about purple? All right. So if we do 10 times 10, we know that that's our base. And then our exponent is going to be the number of zeros, which would be 2. All right. And then your word form would be the second power of 10. Or I say, another way to say it would be 10 to the second power. You can say it either way. The book has us doing the first way, the second power of 10. Okay, you can stop shrinking. I'll just put it down there and move it up for you. All right, let's try this one. 10 times 10 times 10 times 10. All right, you know your base is going to be 10. How many zeros? What's your exponent? 4. Okay, so it's going to be the fourth power of 10. I'm going to leave that big. I'll just put it down here. And I spelled fourth wrong, didn't I? Sure did, Miss Hummel. Oops. Fourth power of 10. All right, so now down here, we're doing a little differently. We're finding the value of 10 to the second power or the second power of 10. So now we're finding the value of that. So now be careful with this because remember what you're doing is you're doing 10 times 10. So that's going to give you 100. Okay? Then here, now here they've expanded this a little bit. They have 4 times 10 to the second power. Okay, so let's break down this first. We have 10 times 10, which we just figured that out, right? Times the 4. All right, so 10 times 10 we said was 100, right? And then times the 4, it's going to give us 400. All right? All right, so now this one, let's break this one down again. So we'll bring that 7 down, and then let's break up 10 to the third power. It's going to be 10 times 10 times 10. All right, so what is 10 times 10 times 10? You should know that it's 1,000 times 7, and that will give you 7,000. Not so bad, huh? All right, what I want you guys to do right now is I want you to practice some problems. So I want you to practice number 6 to 12 on page 25 right now. So you're going to 12, 6 to 12. Okay, practice those guys and we'll check them in a little bit. And then on your homework tonight, you are going to be doing page 27, and you're going to do numbers 1 to 9. All right, so try these out, see how you do on them, and then we will check them tomorrow, and we will try some of the ones on the slide presentation as well. Okay, if you have any questions, let me know.